Okay, we're ready for more Chapter 2. This part of Chapter 2, we're dealing with quantitative data again. And this time we're talking about large data sets. What do we do when we have a large set of data? Now, what do we mean by that? Here I have the information about the minutes somebody spent on a phone, considered a job, I don't know, fixing customer complaints or helping them out. So here we have a list of times that people were spent on the phone. Really not easy to tell whether this is a large data set or not until we start looking at it. And what did we say we always look at first when we talk about quantitative data? Well, first we need to look through the data set and find the minimum and the maximum. Now, you may need to pause and go back. If you didn't write down all those numbers, you're not going to be able to find the minimum and the maximum. 67 is the lowest number, 125 is the highest. Now, if you think about the range between 67 and 125, that's a whole lot of numbers. The other thing is, if you looked at the data set at all when you were looking for the 67 and the 125, there weren't a lot of repeats. So a large span without a lot of repeats means that we probably need to do something different than what we did with Chapter 2 in the small data sets. What we're going to do here is first find the range, and that was 58. That's the thing that told us, so that's probably a large data set. We don't want to list 58 totally different numbers in a frequency distribution, so what we do is we group them. The groups are called classes. In this particular instance, we are going to group them into 5 classes. 5 groups. So what we do is, first step, we find the range, like we just did. Second step, we want to divide those 58 numbers, and we want to divide that into 5 different groups. So we take the range and we divide it by how many classes we want. So we do 58 divided by 5, and that doesn't work out evenly. It works out to 11.6. Now, I want you to realize this is a 3-step process. First, I find the range. Then I divide the range by the number of classes. The last step to find what we're calling the class width is to round that final answer up to match the data. So in this case, our data was a bunch of whole numbers, so I'm going to round 11.6 up to the next whole number, which means my class width is actually going to be 12. Just for clarification, if that had worked out to be 11.2, I still would have rounded up to 12. If that was 55 divided by 5 and it worked out to be 11 even, I would still round up to 12. This always round the class width up. That is a step in finding the class width, not just a new rounding rule. So, I have a class width of 12. What do I do with it? Well, I want to make a frequency distribution, so we start with the lower class limits. Usually there's not a line in between these, but if you missed class, it's easier to do it on this video to visualize. I'm going to talk about one column and then another. The lowest class limit is going to be my minimum. There's no sense in starting this chart before I get to my first data item. So my first class limit is 67. Now, to find the next lower class limit, I take my class width and add it to the class limit I have. So I'm saying I'm going to take 67 plus 12 and that tells me my next class is going to start at 79. How do I find my next lower class limit? The same way. Take 79 and add 12 to it. That gives me 91. Do it again. Add 12. And 3. Now, if I didn't give you this graph that lets you know when you got to the bottom of it, we said we wanted 5 classes. You do this add 12 thing until I have 5 lower class limits. And there we go. Now, I need to know where each class ends. What I have in front of me is where each class begins. So if I have this, my first class starts at 67. I need to know where my first class ends. Well, if my second class begins at 79, I can't have 79 in both groups. So if my second class starts at 79 and I don't want to miss any numbers, my first group needs to end at 78. Now, I could sort of follow that logic down if I want to, or I use my class width. The class width is the distance when you go down the columns. So I add 12, add 12, add 12, add 12, until I get to the end. Now, if I have been using the logic thing where I'm looking back to find the last lower class limit, I add 12. Now what this means is that my first class goes from 67 to 78, 79 to 90, and so on. Now I just start looking at my data. So I've got to go back to that first page where I can see what the data was. And when I do that, I just start making tick marks. You're probably not going to be able to just look at this big list of data and go, okay, how many of those numbers are between 67 and 78? So instead I just look. The very first data entry is 102. 102 is in the third class, so I make a tick mark. The next piece of data, and I don't know why, but I like to go I was going to say I like to go down, but I guess I didn't. I don't know. My next piece of data, what was it? Oh, I got to scroll back up here and look. My second piece of data was 124. Where does that go? I think I put my tick mark in the wrong place. Yeah, I don't know what I did. There we go. I just have the two slides out of order. I go down. So 102 goes in the third class, 71 goes in the first class, 103 goes in the fourth class, and so on. So I keep sticking tick marks in there until I have figured out how many of each number I have in those classes. So you want to pause this while you fill the rest of this chart in, and then check your answer. Figure out how many data items you had to start with. make sure you add up the frequencies, and that equals the same number of data items you started with. In this case, I believe you started with 30, didn't you? 5 by 6 is 30. So make sure that adds up to 30. Now, it won't tell you if you put a data item in the wrong group, but it will tell you if you've missed any, which can happen, especially with quantitative data, if you get interrupted. So this is a frequency distribution, and usually your classes aren't separated into two columns like this. It's just first class is 67 to 78, just a dash in between instead of two columns. And that's all you need unless you're asked to compute more. One of the things we learned how to compute before with the qualitative data is something called relative frequency. We already know how to do that, and we'll do that for this, but with quantitative data, we have something also called cumulative frequency. Relative frequency is the same as it was before. In the first class, I had 3 data items, and that means I have 3 out of 30, that's 10%. So if you'd like to pause and compute the rest of these, now would be a good time to do that. Again, my consistency, relative frequency, I always go to 1/10 of a percent if it doesn't work out even. So make sure you got those correct. Your frequency should add up to your sample size. That's to make sure you didn't miss any data. Your relative frequency should add up to 1 if you do it as a decimal, 100% if you do it as a percent. So a decimal, 1, or 100%. Now these, we had to do some rounding here. We rounded up, we rounded up, we rounded up. This isn't exactly going to be 100%. This is going to be 100.1% if I add it up. Now, since I computed it, I sort of remember rounding up, rounding up, rounding up. So if it doesn't work out exactly 100.0%, I know it's a rounding error. So don't freak out if you're off by 1/10 and you know you had to round. Cumulative frequency, this is another thing that you don't do unless you're asked to do it specifically, and it doesn't seem to make any real sense unless you kind of are in a question that uses it. But basically you start at the top, you start with 3 data items. If I have 3 data items in the first class, the cumulative frequency for the first class is just 3. So, 3 data items in the first class gives you a cumulative frequency of 3. But when I go to the second class isn't asking me how many data items are in the second class. I always start back at the top. So the cumulative frequency for the second class is how many data items do I have in the first and second class combined? And that would be 8. The 3 I started with plus the 5 that were in the second class. When I go to the third class, again, it's not how many are in the third class, it's how many are in all the classes up to the third class. So in the second class I had 8. To find the cumulative frequency for the third class, I have to add another 8. And so on. The last entry should be how many I had in the entire sample, or again, somewhere I have gone astray. If I'm going to make a graph, I need to compute yet another number. And that number is going to be a class midpoint. A class midpoint is what I use when I do computations on the calculator. Class midpoint is what I use when I make a graph. And what does midpoint sound like? It's the middle. So, 67 to 78, those are my class limits. How do I find the midpoint? I add 67 plus 78, I get that answer, and then I divide it by 2. And when I get that answer, it turns out to be 72.5. Don't round these off. Don't call it 73. 73 wasn't the middle. 72.5 is. Now, I can do one of two things. I can continue that pattern for the rest of those. I could do 79 plus 90, get that answer, and divide it by 2. The other thing I can do is remember my class width. Class width is the same distance down any column. So I can add 12 to 72.5 and then add 12 and so on, and that'll give me the rest of my class midpoints. I don't care which way you do it. Either way is fine. Now the last thing I want to do is if I want to make a graph. This is my frequency distribution to make a graph with. I don't want to use these class limits. It makes it messy. So when I go to Excel or when I go to my graph paper, even though I need my class limits to be able to sort my numbers, I use midpoints on the graph. Usually I don't make a pie chart out of quantitative data, although I could. This is a bar chart. A bar chart that has quantitative data on the x-axis is called a histogram. So you have 3 different kinds of bar charts here. A regular old bar chart is qualitative data that is ordinal. So the words on the x-axis are in order. You have a specialized bar chart called a Pareto chart, which still has words on the x-axis, only those words didn't have an order to them, so they're arranged from most popular to least popular. On those kind of bar charts that have words on the x-axis, the bars did not touch. The bars didn't touch to accentuate the separateness of each response. Now when I have an x-axis that has numbers on it, those numbers need to stay in numerical order. You never rearrange the bars on a histogram. And the bars touch, because remember how we made the class limits so that we didn't have any gaps between the classes? We covered all the numbers. Well, that's what the bars touching in a histogram signify. If we have any gaps in a histogram, it's because we've got an actual category, an actual class that didn't have any data that fell into it. Now you still have the same titles on the x-axis, the y-axis, and the entire graph that we had before. So this is a histogram, a bar chart of quantitative data.